Hello everyone, this is a continuation of part 1 of the linear equations of two variables x and y. The linear equation of two variables x and y is just expressed by a graph, as you can see one here. Let's analyze the slope of this graph. This graph is moving upwards or rising as it moves from left to right. To decide on a slope of a graph, we need to have at least 2 points on the graph, or we need to have the graph itself, the equation of the graph itself. Say we have 1 point here. I call it P1, which is got x1 and y1 as 2 coordinates on the graph. And here I have P2 is got x2 and y2. To decide on the value of the x term, we need to create, or we need to make a vertical line towards the x-axis, just the way I do it here. So we can have where x1 is, it's here, x1 is here, and we can have here x2. Obviously, x2 is greater than x1 as it is located on the right side of x1. To decide on the y values, we need to create a horizontal line towards the y-axis like this, which is y2 here. And from the other point here, we have y1 here. The same thing here. y2 is on top of y1, then y2 is greater than y1. Slope is the vertical increase divided by the horizontal increase. In other terms, we can call it rise divided by run. Something like this much horizontal line is run, this much vertical line is rise. Okay, now here let's take one fact from here. y2 minus y1 is greater than 0. x2 minus x1 is also greater than 0. We need to agree on this. y2 is greater than y1 means y2 minus y1 is greater than 0. y2 is greater than y1. So you just take away y1 from both sides. y2 minus y1 is greater than y1 minus y1, which implies y2 minus y1 is greater than 0. The same for x2 minus x1, which is greater than 0. So the slope is y2 minus y1 divided by x2 minus x1. Slope y2 minus y1 divided by x2 minus x1, which is a positive number divided by another positive number. So the result is the slope is positive. Let's go back to the same graph here, and any rising graph, as it moves from left to right, will have a positive slope. Let's create another graph and analyze the slope of the other graph. Say this one here. This graph here drops down as it moves from left to right. Let's analyze that one on the next page. This side is x-axis. The vertical line up here is the y-axis. Let me make it much better this way here. This is the y-axis, here is the coordinate. So I'm trying to analyze a graph that moves downwards as it goes from left to right, this way. If I take two different points on this graph, I will have here on the left side point 1, on the right side point 2. Point 1 will have two coordinates here, x1 and y1. I put it x1 comma y1. Likewise, point to have also two coordinates x and y. Here x2, which is this one here, comma y2, which is this one here. So the slope is y2 minus y1 divided by x2 minus x1, which is equal to, you can see here, y2 is a small number, y1 is greater number because y1 is on the top of y2. So y2 minus y1, which is a smaller number, minus a larger number, which is negative, divided by x2 minus x1. Well, x2 is greater than x1. In this case, negative, no, positive. The second one is positive. So a negative divided by positive results negative. So the slope of a dropping graph is negative. All right, let's just analyze some more slopes of a graph. What about the slope of a horizontal line? Let's create one horizontal line here. We have the y-axis here, and we have an x-axis here. Let's sketch a horizontal line. This horizontal line has got 2 points, say P1 and P2. P1 has an x value of here, x1, and a y value of here, y1. P2 has an x value of here, x2, and the y value is the same again, y1. So slope is y2 minus y1 divided by x2 minus x1, which is, y has got only one value on horizontal line here. So y2 minus y1 is the same thing, y1 minus y1 divided by x2 minus x1. y1 minus y1 is just a difference of same number, 0 divided by x2 minus x1 is positive. 0 divided by positive is 0. So the slope of a horizontal line is 0. Slope of horizontal line is 0. Let's just see a vertical line. What will happen to the vertical line? Once again, let's do the Cartesian coordinate, y here, x here, and let's do a vertical line here. This is the equation of the line, which has got 2 points, P1. P1 has got x1 here, x1, and y1 here, y1. Another point here, P2 has got the same x1. On a vertical line, we have only one x values, or one x value, x1, but the y2 is different here, y2. Slope is y2 minus y1 divided by x1 minus x1, which is positive divided by 0. So a number divided by 0 is undefined. So a slope of a vertical line is undefined. Okay, so interesting. Now, what about, can we just say that the equation of the graph here, which is got an x value x1. So this one, the equation of the graph is just x1. x1 is equal to its value. Okay, x1 is equal, say this one is minus 1, here is minus 2, x1 is equal to minus 2. So the characteristic of this graph is defined by only x. x1 is equal to minus 2. Because the y is going all the way up and down, it's just like 0 y plus x is equal to minus 2. For any value of y, we have 0 here, so x is minus 2 is the equation of this graph. On the other one here, it's all about y. X runs throughout, so y is equal to, say this point is 1, 1. That means 0x plus y is equal to 1. 0x is always 0 for any x value, so this equation is y is equal to 1. So the equation of a horizontal line is y is equal to the value of y. In this case, just 1. So let's just do this more examples, which is a continuation of the previous lesson as well. Then we calculate the slope. Slope is rise divided by run. Here you have y2, x2. Here you have x1, y1. The first one is the x value. Second one is the y value. So 1/3 minus 5/3, which is y2 minus y1 divided by 2 minus 0, which is equal to, here in our understanding numbers lesson, we have some fraction additions. When these two fractions do have the same denominator, we can simply operate the numerator. So here 1 minus 5 divided by 3 divided by 2, which is minus 4 divided by 3 divided by 2. Here 2 means 2 divided by 1, so we have to invert it upside down, and then we give it a multiplication sign. Minus 4 divided by 3 times half, which is by 2. Here we will have 2 minus 2/3 is the slope of the graph containing these 2 points. So a line is always having only one and unique slope. That's because a certain operation, say y increase to x increase, it is just subtraction on the top side, the other subtraction on the denominator side, and then you divide that, you will always have a unique number, just one number. That is the slope of the graph. Given a slope and 1 point, find the equation of the line. Here we have another question. A slope is given, and we are given 1 point. Say this is a line. It's just a line. We didn't put the coordinate or the Cartesian plane here, so we cannot say rise or drop whatsoever. We just put one line, and let's give it 1, 1 is a point on the line. The other point on the line is what we don't know, and then we just only call it x, y. Now we define the slope from here, from these 2 points. The slope is y2 minus y1 divided by x2 minus x1, which is 1 minus y divided by 1 minus x, is the slope, minus 2 over 3. From here, now we can have the equation of the graph. We can multiply both numerator and denominator by minus 1 here to make it convenient for our operation. Y minus 1 divided by x minus 1 is equal to minus 2 over 3. Here we can make a cross multiplication up here. 3 times y minus 1 is minus 2 times x minus 1. Three times y minus 1 is minus 2 times x minus 1. Here we do distributive property. 3 times y minus 3 times 1 is equal to minus 2 times x minus 2 times 1. Here 3y minus 3 is equal to minus 2x plus 2. Here we have two negatives. So negative multiplied by negative is a positive. 3y is equal to minus 2x plus 2. I will take this one to the other side, but the sign has to change because it's just adding my plus 3 on both sides. Plus 3. When you add plus 3 on both sides to maintain the balance, this will be 0, so you will have a plus 3 on the right hand side. So 3y is minus 2x plus 2 plus 3. 3y is minus 2x plus 5. Divide both sides by 3. Y is, it's just 1y, minus 2 over 3x minus, plus 5 over 3. Pardon? So this 3 can divide both separately. So this is what? The equation of the graph. From this equation, y is equal to mx plus b, the general form of a linear variable with a linear equation with two variables. We can just take the slope as minus 2 over 3 and the y-intercept as, just give 0 for the x value on the y-intercept, 0, 5 over 3. Why we give 0 for the y-intercept? At a place where the y-axis is intercepted by the graph, say here, the corresponding value of x is always 0. When you're on the y-axis, corresponding x value is 0. When you're on the x-axis, corresponding y value is 0. So for x-intercept, we give a value 0 for y, and for the y-intercept, we give a value 0 for x. Let's just do that in this example, for instance. Y is equal to minus 2 over 3x plus 5 over 3. Y is equal to minus 2 over 3x plus 5 over 3. This is a graph. If we want to know the y-intercept, we give 0 for x here. Y is equal to minus 2 over 3 times 0 plus 5 over 3. This part is 0. Y is equal to 5 over 3 or 0, 5 over 3. The same thing, if we want to know the x-intercept of this graph, we give 0 for y. Y is equal to minus 2 over 3 x plus 5 over 3. Let's give 0 for y. Minus 2 over 3 x plus 5 over 3 is equal to 0. Minus 2 over 3 x is equal to minus 5 over 3. Divide both sides by minus 2 over 3 just to maintain only x on the left side. Minus 2 over 3. X is equal to negative divided by negative is positive. 2 over 3 will be upside down, inverted, and then be multiplied by the numerator. X is 5 over 3 multiplied by 3 over 2. This cancels out, which is 5 over 2. So the x-intercept is, first put the x value here, 5 over 2, then the y value, 0. We are given a slope and 2 points once again to find out the equation of the graph, which is the same thing what I have done before. And let's go to something else. It is again the same. The slope is given, and then you are given 1 point on the graph. Just do it, and then give me the on the comments section what you get. What is the equation of the graph of this one? Let's see something else here. Given equation of a line, can we find slope and y-intercept? That is easy. When we are given a line in the form of y is equal to mx plus b, we put it in this form. Then the slope is the coefficient of x here, and the y-intercept is x comma b. Let me give you a few more examples on this one if required. This is the equation given. We have to put it in the format of y is equal to mx plus b. This will help us easily to find out the slope and the y-intercept. Here is the slope, here is y-intercept. 2y plus 4x minus 2 is equal to 0. 2y plus 4x is equal to 2. Now I am adding plus 2 on both sides. Then this 2 will cancel out and it is 0 on the left. On the right I will have 4. The same thing again. 2y is equal to minus 4x plus 2. I have added a minus 4 on both sides. This cancels out. Then 2y is equal to minus 4x plus 2. I divide both sides by 2. Here I will have 1y is equal to minus 4 over 2x plus 2 over 2. This denominator is for both. So y is equal to minus 2x plus 1. So the slope is minus 2. And the y-intercept is give x 0 and y just 1. Here is another example. I leave this one for you and put the answer in the comment. Let me do this one. 4x minus 6y minus 1 is equal to 0. 4x minus 6y is equal to 1. Minus 6y is equal to minus 4x plus 1. Because this is a plus 1 here. Y is equal to minus 4x divided by minus 6 plus 1 divided by minus 6. That means I'm dividing everything by minus 6. So I will have y only on the left side. Minus, this is a plus. Minus divided by minus is a plus. Plus 2 over 3x. The next one is a minus. Minus 1 over 6. So slope is 2/3. Y-intercept is x value 0. Y minus 1 over 6. Here you are given 0x plus 6y minus 2 is equal to 0. 0x, the coefficient of x is 0, so no need to write it. It is just a 0 plus 6y minus 2 is equal to 0. Again, 0 is not required here to be written. 6y minus 2 is equal to 0. 6y is equal to 2. Y is equal to 2 divided by 6. Y is equal to 1/3. It means this graph is a horizontal graph having the value of y is this y-axis here, the x-axis here, y-axis here, you have 1/3 here. So this is a graph. Y is equal to 1/3. What is the y-intercept of this graph? That's just 0, 1/3. 0, 1/3 is a y-intercept. Does it have x-intercept? Actually, no, because it's a horizontal graph. Y is equal to 1/3. For x-intercept, we have to give 0 for y. When we put 0 here, 0 is equal to 1/3. So we end up with a false statement. 0 is equal to 1/3. Simply false. So when we come up with a false conclusion, it means it's not existing. So when we try to calculate for x-intercept, we end up with a false conclusion. So there is no x-intercept. The other way around here, 0y plus 4x minus 4 is equal to 0. This one is 0. 4x minus 4 is equal to 0. 4x is equal to 4. I divide both sides by 4 here. X is equal to 1. This is a graph of x is equal to 1. This x-axis here, y-axis here, I have 1 here. This is a graph here. X is equal to 1. What is x-intercept? It is just 1. For x-intercept, we have to write x first, 1, and then give 0 for y. The x-intercept is 1, 0. What's the y-intercept? For y-intercept, we have to give 0 for x. So x is equal to 1. Put 0 in place of x. 0 is equal to 1. This is false. That means we don't have y-intercept. No y-intercept here. In the previous example, no x-intercept. No x-intercept. So a horizontal line which is not the x-axis itself will have no x-intercept. A vertical line which is not the y-axis itself will have no y-intercept. What will happen here? 0x plus 0y minus 4 is equal to minus 4. 0x is 0, 0y is equal to 0, minus 4 is equal to minus 4. It is not a mathematical expression at all, because both x coefficient and y coefficient are 0, means we don't have any operation to draw a graph or whatsoever. We just have a statement to say true, just true. But it's not an equation. The same thing here, 0x plus 0y minus 2 is equal to 6, minus 2 is equal to 6. This one is a false conclusion. This upper one here is a true conclusion. However, for a linear equation of two variables, at least one of them should be different from 0. One of them should be different from 0. If both coefficients of x and y are 0, it doesn't work like that. So the next thing is a simultaneous equation of two variables. Simultaneous means happening at the same time, right? Okay. What is happening at the same time? Say one graph is here and another graph is here. What is happening at the same time on this graph? A point exists on both at the same time. This one here, x, y. This is a point existed on both lines of the graph. So a simultaneous equation will help us to find out 2 points, 2 coordinates, a point but with 2 coordinates x and y, 2 values x and y that are on both, both equations of the graph. Just like this. This one is graph 1. This one is graph 2. Graph 1 or equation 1 we can call it. So these two coordinates or a point is on this graph at the same time on this graph. That means when we put the values in place of x and y, both graphs will be true. So what is the point which is on both equations? Let's do that one on the next page. 2x plus 3y minus 1 is equal to 0. 2x plus 3y minus 1 is equal to 0. And the other one is x minus 2y plus 2 is equal to 0. X minus 2y plus 2 is equal to 0. When we are given two equations which represent two different graphs, we need to have a technique of eliminating one of the two variables, either x or y, whichever possible. Then we will have an equation of one variable. We simply calculate for it. Once we get the value of that variable, we substitute that value in one of the two equations above to find out the other point, the other value. Here it's easy to multiply the second equation by minus 2 so that the 2x will be added with minus 2x to be eliminated. The x value will be removed. The variable x will be removed by that. So how do I multiply the whole equation by minus 2? The second equation is going to be minus 2 times x is minus 2x. Minus 2 times minus 2 is a plus 4. And then y. Minus 2 times 2 is a minus 4 is equal to minus 2 times 0 is a 0. Now we have the third equation here, this one here. Then we can use the first equation here because our strategy is just to use the first equation. So the first equation, I will get it down here. 2x plus 3y minus 1 is equal to 0. Now I will add these two equations. Minus 2x plus 2x is 0. 4y plus 3y is 7y. Minus 4 plus minus 1 is minus 5 is equal to 0 plus 0 is 0. 7y minus 5 is equal to 0. 7y is equal to 5. Y is equal to 5 over 7. Now I have the y value. I can put this y value in one of the above two original equations to find out the corresponding x value. I like to take the second one. It looks a bit simpler. X minus 2y plus 2 is equal to 0. X minus 2, y is 5 over 7, plus 2 is equal to 0. X minus 2 times 5 is 10 over 7, plus 2 is equal to 0. Yeah, okay, let's continue now. Now, I take all the numbers constants on the right hand side. X is equal to 10 over 7. I have to change the sign into a plus here. And then this plus into minus. Minus 2. X is equal to 10 over 7 minus 2. To do this subtraction on the numerators, this denominators has to be the same. 1 is 7, 1 is 1. We cannot do it at this stage. What we have to do, we multiply both numerator and the denominator of this number, which is minus 2, by 7. As we are multiplying it by same values, so it is just like 1. We are multiplying a number by 1, the value will not change. So x is equal to 10 over 7 minus 14 over 7. X is equal to 10 minus 14 over 7, which is minus 4 over 7. So in the form of x comma y, the point which exists on both graphs is x value is here minus 4 over 7 comma y value is here 5 over 7. So that means this point is on both graphs at the same time. So if we put this value, x and y values, in any of the two graphs, original graphs, we must have a true statement. The whole equation has to end up with true. Let me do the first one. 2x plus 3y minus 1 is equal to 0. 2x plus 3y minus 1 is equal to 0. 2x plus 3y minus 1 is equal to 0. I want to make sure I have the correct equation. 2x plus 3y minus 1 is equal to 0. The points are minus 4 over 7, 5 over 7. Minus 4 over 7, comma 5 over 7, which is the point on both graphs actually. But we are only checking on one graph, and I leave the other one for you. 2x plus 3y minus 1 is equal to 0. 2x is minus 4 over 7 plus 3y is 5 over 7 minus 1 is equal to 0. 2 times 4 minus 8 over 7 plus 3 times 5 15 over 7 minus 1 is equal to 0. 7 is same for both as a denominator. Minus 8 plus 15 minus 1 is equal to 0. Here we have 15 minus 8, which is 7. So on the upper side we have 7 over 7, this side, minus 1 is equal to 0. 7 over 7 is just 1. 1 minus 1 is equal to 0. 0 is equal to 0. This is true. We end up with a true statement, means it is true that this point is on the graph. This point is on the graph. Okay, the other point, you can verify the same point with the other equation here. X minus 2y plus 2 is equal to 0. You can verify the point, which is the point here, x minus 4 over 7, y 5 over 7, is also existing on the second equation, which is x minus 2y plus 2 is equal to 0. You just try that one, and if you find something else, just put it on the comment, but you must end up with a true statement, like 0 is equal to 0, 1 is equal to 1, something like that. We have another equation here. Let's do the same technique. So let's eliminate once again x from here. To eliminate x, on the first equation I have 4x. On the second one I have 2x. I need to multiply the second equation by minus 2 to find out minus 4x also here on the second term. And then when I add it, it's gonna be just like 0 cancels. It cancels out to be 0. Then I will have only variable y. That's what I expect. Then let's see what I will get then. So the first equation, 4x minus 4y plus 2 is equal to 0, equation 1. Second equation, 2x minus 2y plus 1 is equal to 0. I multiply this one by minus 2. Minus 4x plus 4y minus 2 is equal to 0. Now I have this one here and this one here. These are my interests at this time. Let's add these two. 4x minus 4x, 0. Minus 4y plus 4y, 0. Plus 2 minus 2, 0 is equal to 0. 0 is equal to 0. I end up with just a simple statement to say 0 is equal to 0, which is true. It means that every point is true on this two graph. Every point which is true on the first graph or the first equation is also true on the second equation. In other words, these two equations represent one in the same graph. One in the same graph. It's just like one graph is this one here. I use the blue for the second graph. The second graph is this one here. What does it mean? It means these two equations represent the same graph. The same graph. Let's try another one here. Equation number 1, 2x plus 2y minus 2 is equal to 0. Equation number 2, 2x plus 2y minus 4 is equal to 0. Let's do simultaneous equation on these two. I'd like to eliminate x once again. The value is the same here, 2x, but the sign is different. The sign is the same. Both are positive. I want one to be positive and the other one negative to cancel out. So I multiply the second equation by minus 1. Now 2x plus 2y minus 2 is equal to 0. The second one is minus 2x minus 2y minus times minus is a plus 4 is equal to minus 1 times 0 is 0. X cancels out, y cancels out. I will have on the constant here 4 minus 2, 4 into here is equal to 0. 2 is equal to 0. It is a false. When I have a false conclusion on these two equations, that means there is no way these two graphs will intersect. The condition in which two graphs will never intersect is that when the two graphs are parallel lines here. Two lines are parallel means whatever they have extended on both sides, they will never touch each other. They will never cross each other. The slope is the same. If two graphs do have the same slope, but of different y-intercept, then they are parallel. One graph is here. It has this y-intercept y1. Another graph is here. It has y-intercept y2. A third graph here. It has got y-intercept y3. The rise of these graphs, rise divided by run is the same, means they're just parallel. The equation is different, of course. y is equal to m1 plus y1, m1x plus y1. The slope is the same. Say I will call it m, okay? The first graph is here, y is equal to mx plus y1. Second one, y is equal to mx plus y2. Third one, y is equal to mx plus y3, whatever. The difference is only the y-intercept. They have the same slope. So these parallel graphs will never intersect each other. In this case, when we are given two equations and when we try to do a simultaneous equation to find out a point that satisfy on both, then we end up with a false conclusion. When we end up with a true conclusion, that means the two graphs represent one and the same. When we end up with a false conclusion, that means the two graphs are parallel. They never intersect each other. Let's see this one. The first one is 2x plus y minus 2 is equal to 0. The second one is not having y because y is free. It means like 0y. It's just like x plus 0y plus 4 is equal to 0. So no problem. Now we have only to eliminate x. Actually, we don't need to eliminate x. We simply take the second equation here. X plus 4 is equal to 0. X is equal to minus 4. This graph is x is equal to minus 4. When we try to represent it here, let me draw that one here. Minus 1, minus 2, minus 3, minus 4. This is a vertical graph here, vertical line. X is equal to -4. What about the second one? For the second one, let's take the equation and then put the value of x as -4. 2x plus y minus 2 is equal to 0. 2 times -4 plus y minus 2 is equal to 0. Minus 8 plus y minus 2 is equal to 0. Y minus 10 is equal to 0. Y is equal to 10. So we have x minus 4, y 10. Somewhere here. X minus 4, y is 10. X is minus 4, y is 10. It's where they intersect. Okay, let's take that graph again and then try to find out the y-intercept. We have 1 on this graph. Let's get another point on that graph. 2x plus y minus 2 is equal to 0. For the y-intercept, we have to give 0 for x. 0 plus y minus 2 is equal to 0. Y is equal to 2. Here. So if we have 2 points on a graph, we can just join them by a ruler to show you the diagram of the graph, which is 2x plus y minus 2 is equal to 0. I will write it again. 2x plus y minus 2 is equal to 0. That's it. What about the slope of this same graph? Slope, let me take another page. 2x plus y minus 2 is equal to 0. 2x plus y minus 2 is equal to 0. 2x plus y is equal to 2. Y is equal to minus 2x plus 2. Y is equal to mx plus b. Slope is equal to minus 2. Y-intercept is equal to 0, 2. So the slope is minus 2. So this is the true set for these two graphs. So when x is equal to 4 and y is equal to 10 is a point which is on both graphs. That means if you put these coordinates, they make both equations true. Let's check the graph. 2x plus y minus 2 is equal to 0 by minus 4, 10. 2x plus y minus 2 is equal to 0. 2x plus y minus 2 is equal to 0 is the graph. Let me just get the 2 points. These are minus 4 and 10. X is equal to minus 4, y is equal to 10. 2 times minus 4 plus 10 minus 2 is equal to 0. Minus 8 plus 10 minus 2 is equal to 0. Minus 10 plus 10 is equal to 0. Yes, 0 is equal to 0 is true. So the point x comma y as minus 4 comma 10 is on the graph. On the graph, 2x plus y minus 2 is equal to 0. It's also on the graph x is equal to minus 4 because we can simply see x is minus 4. Okay, this one is the same as what we have done right now. So I leave it for you. You just try it and then put comment on the comment section. Thank you so much for being with me all the way, nearly, I don't know, 50 minutes probably. And I appreciate that. So I like to say thanks. So next videos will come, I can say shortly. with quadratic equations. Quadratic equations. So you need to subscribe, and you can have the next videos. Thank you so much and have a good day. Bye bye.